Welcome to Maths and Science by IITian channel. In this lecture, I will be continuing with the algebra of sequence and series. Practice questions. Sequence and series practice questions. In the last class, I have discussed about one series in which we have used the property of this partial property of this particular equation or series. Now, today in this lecture, we will be trying to find out for various values of exponent p, what will be the sum of n is equal to 0 to infinity n to the power of p divided by factorial n. Here exponents are involved, infinite series is involved, and also factorials in denominator are involved. And how to find out this particular series value? This series value involves finding the Bell number which is BP, and from Bell number we will be finding the series that will be E into Bell number. Then what is that Bell number? Bell number is a very crucial and important concept in series and sequence and series involving natural logarithmic, E value and a series. Series is connected by E multiplied by Bell number BP, and how to understand it, what are its meaning, and how to develop that relation we will discuss here, and let us see what is the Bell number and how Bell number varies with P. Let us try to solve it. Let's go further. Problems may come or questions may be asked in JEE Advanced, JEE Mains, Maths Olympiad or CSIR Mathematics involving this type of sequence coupled with some other combinations. Whenever you find a series or sequence this way, you please try to invoke the Bell number concept which we are going to discuss now in that particular part of the series, and try to find out the final value as we have done in the previous example. Please see my previous video on sequence and series, where we have got the answer as 17 E by 6. Now let's go further to solve it. Find the value of series sigma n is equal to 0 to infinity n to the power of p by factorial n. This value changes as p changes. Let us try to understand what it is. For example, let us try to understand the series first, what it is being asked. Let us try to understand if p is equal to 0. What happens? Series will be sigma n is equal to 0 to infinity n to the power of 0 divided by factorial n. that is equal to sigma n is equal to 0 to infinity 1 by factorial n. That will be 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial, and its value is E. This is a standard series. How we have got it? Let us see now. We are only applying different p values. P is equal to 1. What happens? Sigma n is equal to 0 to infinity n to the power of 1 by factorial n. That is equal to sigma n by factorial n. That means 1 by 1 factorial, 2 by 2 factorial, 3 by 3 factorial, plus and so on. This value is also we can say 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial, because 3 by 3 factorial is nothing but 1 by 2 factorial. 3 get cancelled this way. This is equal to E. This is also a standard value from the definitions of E. That means there is a connection between E and the series what we are talking about. Now, if P is equal to 2, what happens to the series? Sigma n is equal to 0 to infinity n square by factorial n, because P is equal to 2. That means 1 by 1 factorial plus 2 square by 2 factorial plus 3 square by 3 factorial plus 4 square by 4 factorial plus and so on. And as we know, for P is equal to 0, the value is E. For P is equal to 1, the value is E. And this sum, let us say S0. This sum, let us say S1. This sum, let us say S2. There is one formula we can use. S2 is equal to (1C0 S0 plus 1C1 S1). That is equal to 1 into E. What is this? From permutations and combinations and binomial theorem. If you see the permutations and combinations, from that we got this value. Now what is 1C0? Factorial 1 divided by factorial 1 minus 0 divided by factorial 0 into S0 plus factorial 1 by factorial 1 minus 1 factorial 1 into S1. That implies S2 is equal to, this is the formula. Please try to understand how I am developing it. 1 factorial by factorial 1 factorial 0 into S0 plus 1 factorial by factorial 0 into factorial 1 into S1, that is equal to 1 into E. S0 is E. We know S1 is also E. Plus 1 into E, that is equal to 2E. S2 is equal to 2E. Then, if P is equal to 3, sigma n is equal to 0 to infinity n to the power of p by factorial n is equal to sigma n is equal to 0 to infinity n cube by factorial n. That is equal to, let us say it is as 3, some 3. This can be written as 3 minus 1 C0 into SC0 plus 3 minus 1 C1 S1 plus 3 minus 1 C 2 S2. What is 3 minus 1? That is 2C0 S0 plus 2C1 S1 plus 2C2 S2. From permutations and combinations, this value can be 1 into E, S0 is E, plus 2C1 is nothing but 2, S1 is E, plus 2C2 is nothing but 1, into 2E, S2 is 2E, that means 2E, 2E, 4E, 5E. Now, we will go for P is equal to 4. What happens? S4 is equal to sigma n. Why I am going little bit in elaborated manner? Because it is a good concept which you should be able to solve it without any problem. Because if any series and sequence given having this type of series built in, then for this particular part of the series you can apply this formula straight away. N to the power of 4 by factorial n. N to the power of 4 means 4 minus 1 is 3C0 into S0 plus 3C1 into S1 plus 3C2 into S2 plus 3C3 into S3. You just see how simple it is. 3C0 is nothing but 1 into E plus 3C1 is nothing but factorial 3 by 3 minus 1 factorial 2 factorial 3 by factorial 2 is nothing but 3. Into E plus 3C2. 3C2 is factorial 3 by factorial 3 minus 2 into factorial 3 factorial 2. That is nothing but 3. S2 value is 2e plus 3c3 is 1. S3 value is 5e. What is its value? 1 plus 3, 4, 4 plus 6, 10, 10 plus 5, 15, 15e. Similar way, you can find out n is equal to 5 implies sigma n is equal to 0 to infinity n to the power of 5 by factorial n, that is equal to S5 is equal to sigma n is equal to 0 to infinity n to the power of 5 by factorial n is equal to 52e, which I have asked in the previous example. If you see, I have asked you to calculate. This is 52e. Now, like this, it is not n, sorry, it is p. For example, p is equal to some m. P is equal to some m. That implies sigma n is equal to 0 to infinity n to the power of m by factorial n, that is equal to Sm is equal to m minus 1 C0 S0 plus m minus 1 C1 S1 plus up to m minus 1 C m minus 1 into S m minus 1. That implies, this is the standard formula, you please remember for this type of things, sum is equal to Sm m minus 1 in 1 C 0 S0 plus m minus 1 C1 S1 plus up to m minus 1 C m minus 1 S m minus 1. Please apply this formula and get the value of this series. Hence, what is the answer we have got is, this is the answer we have got. For various values of p, because it is not a standard value, it depends upon the value of p. Therefore, we write the answer as sigma n is equal to 0 to infinity n to the power of p by factorial n is equal to p minus 1 c 0 s0 plus p minus 1 only c1 s1 plus up to p minus 1 c p minus 1 s P minus 1. This is the answer. It depends upon the value of P. And here this is in the multiples of E. You just see. First value is E, second value is 2E, next value is 5E. That means this is nothing but E into some value BP. This is Bell number. N to the power of P by factorial N is equal to E into BP. BP is the Bell number corresponding to P value. This is called as the Bell number corresponding to P. Now, what are the Bell numbers for various values? If P is equal to 1, let us say P is equal to 0. What it happened? We have started our calculation with P is equal to 0. Let us make the table of the Bell numbers from the above discussion. Bell numbers, please remember them. Instead of calculating, you can easily calculate also, but however, from series n is equal to 0 to infinity, n to the power of P by factorial n is equal to Bell number P EBP. From this, let's make a table. Bell numbers, P is equal to how much, and we will get Bell number BP, and we will get summation series. This is equal to SP rather. We will write for various P. For remaining values, please calculate the Bell numbers. Now, let us calculate the Bell numbers. We have already calculated for some, and let us list them. You have seen how we got the Bell numbers and how we got the values of summation. Now, let us say, if P is equal to 0, what is the value we have got? S0 is equal to E, 1 into E. This is 1 into E. That means Bell number is 1. Bell number is 1 and SP is E, and P is equal to 1 means Bell number is 1 and value of the summation series is E, and P is equal to 2. What we have got? Bell number as 2 and it is 2E. You just see, P is equal to 2 we have done. Bell number as 2E. P is equal to 3, Bell number is 5 and SP is 5E. P is equal to 3, Bell number is 5. This is 5e. And P is equal to 4. For P is equal to 4, it is 15e. 15e. And P is equal to 5. It is 52e. Bell number is 52, summation series. Now, for brevity's sake, for 6 you please calculate and comment in the comment box. This is BP is equal to Pth bell number. From this, you can understand how beautiful or important the series n is equal to 0 to infinity n to the power of p by factorial n is equal to e into bell number p, which is depending upon bell number p, and bell number p is calculated for various p value. And with this, I want to conclude this lecture stating that it is involving factorials, exponentials, the value e of natural logarithm, and bell number, value of e. How we have got the value of e? Value of e from the series 1 by 1 factorial plus 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial is equal to e. Try to prove that. If you have any doubts, I will prove it. E is equal to 1 by 0 factorial plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial. Please remember this e value in series form. How we have got it? This you please try to do your homework and the series of e and try to understand how we have got it. If you know how we have got this value, then other things are very easy to understand. I will give the hint. E to the power of x is equal to sigma n is equal to 0 to infinity x to the power of n by factorial n. This is from the definition. Use this and get this equation. I will be doing it in the next class to find the value of e for various conditions. Now, you got the value bell number, you defined the value of e, how it will be, then this series has become e into bell number and for various values of p, how we got the bell number? We have here, and we got the bell number as from this equation. We have got the bell number and we have got the value of this particular equation. Now, as I have told you, please try to find out the bell number and series value when p is equal to 6. Take it as a homework and please do it. And also for value of c, how we have arrived at this value, please try to understand and comment in the comment column. I will respond. Otherwise, in the next class, I will be taking up this particular solution for this, how we have arrived it. With this, I want to conclude this lecture. Thank you for listening to me. Thank you for seeing my lecture. Best of luck to everybody. And please, if there is a value addition to your knowledge because of this lecture, please hype this lecture or video and share this lecture and video and subscribe to my channel, Maths and Science by IITian. Thank you. Best of luck to everybody. This is a very good example. Please see the video in full and previous video also. Please try to understand the concepts. Thank you. Best of luck.